projects. In this video, we are going to explain about a project titled Lung Cancer Detection Using Deep Learning. The integration of the deep learning in the lung cancer detection signifies a remarkable leap in medical technology. By tapping into the capability of the sophisticated artificial neural network, this approach aimed to revolutionize the accuracy and efficiency of diagnosing the lung cancer. With access the vast amount of medical imaging data, the deep learning algorithm can effectively analyze the intricate pattern and anomaly that may indicate of lung cancer. This cutting-edge application holds the promise of early and precise detection, empowering the medical professional with a powerful tool to identify the lung cancer. Consequently, this transformative technology has a potential to save lives and elevate the standard of patient care and the ongoing battle against the lung cancer, leading to the improved outcome and the better prognosis for the patient worldwide. Embracing this groundbreaking advancement can significant the enhancement of the medical community ability to combat this devastating disease and provide the timely intervention for those in need. The primary aim of this project is to create a comprehensive lung cancer detection system by utilizing the advanced learning algorithms, specifically the convolutional neural network, support vector machine, and the k-nearest neighbor. Each algorithm plays a crucial role in the process, with CNN extracting the feature images, KNN identifying the patterns. By combining the strengths of these algorithms, the objective is to significantly improve the accuracy and the efficiency of the lung cancer detection. The project's extensive training and the evaluation on the diverse medical image data sets ensured the development of a robust and reliable model. Ultimately, this system aimed to empower the medical professional in making the early and precise lung cancer diagnosis, leading to the improved patient outcome and more informed health care. Embracing this advanced machine learning technique can revolutionize the lung cancer diagnosis, offering the better prospect for patients and contributing to advancement of medical technology and the fight against the cancer. These are the basic requirements that are needed to build this project. The software requirements: Python IDE with version of 3.7, Anaconda with version of 3.7, or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. And this step you will import the necessary Python libraries and the frameworks required for the implementation, like of TensorFlow for creating the CNN, sklearn for SPM and KNN, NumPy for numerical operation, Matplotlib for visualization, and Flash for building the web application. And the second step is data exploration. Here we analyze the data containing the medical images related to the lung cancer. This exploration helps in understanding the distribution of images, identifying the potential data imbalance, and gaining the insight into the characteristic of the cancerous and non-cancerous, of benign and malignant too. And the third one is splitting into the training and the testing. Here the dataset is divided into the two parts, a training set and the testing set. The training set is used to train the SVM, KNN and CNN model, while the testing set is used to evaluate the performance and the generalization. And the fourth step is image scaling and processing. Before feeding the image into the CNN, pre-processing is essential. This involves resizing the images to the standard size, normalization and the augmentation technique to augment the dataset for the better model performance and the generalization. And the fifth step is building the model. Here, three different machine learning models are built for the lung cancer detection. The first one is CNN. CNN is a deep learning algorithm specifically designed for the image recognition. In this project, the CNN plays a central role in the lung cancer detection by automatically extracting the relevant features from the medical image. The algorithm utilizes the conventional layer to detect the local pattern, pooling layer to reduce the spatial dimension, and the fully connected layer for the classification. Training a CNN model on the large dataset of the lung images enable it to learn to distinguish between the lung patterns, resulting in the accurate and efficient lung cancer detection. And the second one is SPM. It is a powerful machine learning algorithm used for the classification task. In the context of the lung cancer detection, SPM can be employed to classify the extracted features from the lung images. By identifying the hyperplane that best separates the two classes, SPM can create a decision boundary that maximizes the margin between the classes, where the SPM ability to handle the high-dimensional feature space and the non-linear relationship makes it a suitable candidate for the lung cancer classification. And the third one is KNN. It stands for K nearest neighbor, is a simple and the initiative machine learning algorithm used for the classification and the regression task. And the project KNN is applied to classify the lung image based on the similarity to other labeled images and the dataset. The algorithm works by finding the K nearest labeled data point to the given test data point in the feature space and assigning the majority class label from those neighbors. KNN is particularly useful for the small dataset and be combined with the feature extraction method for the lung cancer detection. And the next step is accuracy comparison graph. After training and testing the CNN, SPM and the KNN model, the accuracy of each model is evaluated. A comparison graph is generated to visualize and compare the performance of each algorithm in the lung cancer detection. And the next step is training the model. The CNN, SPM and KNN models are trained using the training data set. The CNN is trained on the images while the SPM and KNN are trained on the extracted features. The model learns from the input data and the corresponding label to make the prediction. And the next step is user gives the input. A user-friendly interface for the lung cancer detection is using of the Flask web framework. Users can upload their own lung image and provide the URL of the image they want to test for the lung cancer. And the next step is the given input is pre-processed for prediction. Once the user submits the input image, it needs to pre-process to match the format required by the CNN, SPM and the KNN model. This includes resizing, normalization and the feature extraction to prepare the input for the prediction. And the next step is trained model is used for the prediction. The pre-processed input image as extracted, the features are passed through the trained CNN, SVM and the KNN model respectively. Each model make a prediction based on the input determine the likelihood of the lung cancer. And the last one is final outcome is displayed. The prediction from the CNN, SVM and KNN model are presented to the user through the web application. The user can see the outcome and compare the prediction from the different model, helping to make the informed decision about the lung cancer detection and the potential healthcare intervention. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it. The dataset folder containing of the benign cases, malignant cases and the normal cases folder containing of the various images within it. And the output folder containing of the training and the val folders and the sample folder containing of the test cases that will be used to test the performance of the model. And the static folder containing of the various images of files within it like CSS, JavaScript, model and upload files. And the template folder containing of various HTML files like of after, home, index, sign in and sign up pages within it. And the app is an py file which likely contains the information related to the front-end logic. And it includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the model is an pickle file likely contains the information related to the algorithm and is loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file that is used to store the user information. And the overall project code is present in the notebook IPYNB file as a combination of code, graph, and output all in one place. And for the execution of the project, we need to copy this code folder path and then open the Anaconda prompt. Here we need to change the location of the disk by the F because our disk is located at the F. Our code folder is located at the F disk, and then write a command cd space and paste this code folder path. By this it will change the directory to the code folder path, and then click on enter button and write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on enter button. By running this app.py file, the Flash framework will host the application locally at the address like this. We need to copy this address and paste it on any of the web browser. I am pasting this link and clicking on the enter button. Here we redirected to the page containing of the title and some information about it and the sign up button. Here click on the sign up button. It will redirect to the page containing of some necessary details that are need to be filled in to create an account. But my account is already created. That's why I'm using the sign in button. Here it will redirect it to the sign in page containing of the username and password, and we need to fill those details. And then click on the sign in button. Here we redirect it to this index page containing of the choose file and the upload button. Then click on the choose file button. It will redirect it to this folder containing of the various images that will be used to test the performance of the model. I am selecting the one image and then click on the open button and then click on the upload button. Here it predicted the image as of Bandgend is detected, and by using the try again button, here we redirected to this index file page and choose file and upload buttons by clicking the choose file button and selecting the one image and click on open button and then click on the upload button. Here the predicted result is of classified as malignant, and by using the try again button we redirected back to this index page, and by clicking on the choose file button and selecting any one of the file format and then click on open button and then click on the upload button. Here the predicted result is of normal. In this way we can predict the lung cancer detection by using the deep learning algorithms and in conclusion, the implementation of CNN, SVM, KNN algorithm for the lung cancer detection has showcased the significant advancement in the medical technology. The project results demonstrate the power of deep learning with the CNN and extracting the intricating the feature from the medical image, while SVM and KNN effectively classify and identify the pattern and the data. This comprehensive approach has led to improved accuracy and efficiency in the lung cancer detection, enabling the early and precise diagnosis. By providing the medical professional with a reliable tool for the timely intervention, this project holds the potential to save life and elevate the standard of the lung cancer care, making a profound impact on the patient outcome and the healthcare practice.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.